In this video, I'm going to demonstrate how to deploy the TKG management cluster. So I'm logged in to my fully configured Bootstrap machine, which has the kubectl and Tanzu CLI installed. So to start the TKG deployment user interface, I'm just going to start by checking the IP address of the machine. So I'm going to issue ifconfig. And we can see that the IP address that's been issued to the Bootstrap machine is 172.19.72.26, which is this one over here. So we're going to use the Tanzu CLI to bind the UI to this IP address on port 8000, which we added the IP tables rule for previously. So the command we're going to use is Tanzu management-cluster space create --UI, which means we want to start the UI and we want to bind it to 172.19.72.26 on port 8000. And by default, it opens the UI in a browser window. We don't have a GUI on our Bootstrap machine, so we don't want to do this. So we're just going to say browser none. So we're going to run that command, and you'll see it will start serving the Kickstart UI at that IP address and port. And we should be able to open a browser window now and navigate to that user interface. So switching over to a browser window, this is the view of the user interface that you will see. It has the ability for you to go and browse the documentation. It also has a dark mode if you wish to use that. But the primary functionality is provided by these three deploy buttons for three separate infrastructure providers that are supported by TKG. So in our case, we're deploying to VMware vSphere. So I'm going to click deploy here. And this will bring up a window with a number of configuration parameters that we're going to use to configure the way that the TKG management cluster is deployed. So the first section of the configuration requires us to configure the access settings, or the location and the access settings for the IaaS provider. So in this case, it's the vCenter server. So I'm going to put in the IP address of our vCenter server, which is 10.220.30.1. I'm going to enter in the username and password and click connect. We're going to get a pop-up for the SSL thumbprint. I'm going to click continue. And then it's going to pop up a window saying that we've got vSphere 7 installed. And if you're not aware, there's two ways to install TKG on vSphere 7. The first is what's called vSphere with Tanzu, or also called workload management. And this is a very tightly integrated version of Kubernetes, which is provided with vSphere 7. And the other is to deploy a TKG management cluster, which is what we're going to do. So this is separated from vSphere with Tanzu, and it allows us to deploy TKG management cluster in a slightly more configurable way. So I'm going to click deploy TKG management cluster. And we can see that we have connected correctly to the IaaS provider because it is able to gather information on the data center from the vCenter server. So the final required piece we need to input here is the SSH public key, which will allow us to connect to the VMs that the management cluster creates. And this was the public-private key pair that we created as part of the Bootstrap machine preparation. So I'm just going to paste that in here, based on the one we generated. So I've just pasted the public RSA key that we generated. And once that's done, I'm going to click next. Now the second part of the configuration is asking us around the cluster settings. So this is providing two options for deploying the control plane nodes, development and production. The main difference between these two is that development will deploy a single node control plane node, for the management cluster, whereas production will deploy 3 control plane nodes, so 3 VMs. In our case, we want to deploy it in a production plan, so I'm going to use this one, and I'm going to choose to deploy it with a extra large instance type, which means that each VM will be deployed with 8 CPUs, 32 gigs of RAM, and 80 gigabytes of disk. I have no issue with resource exhaustion in this lab, so I'm just choosing the biggest type possible. You will also see that the same instance type is chosen for the worker nodes, but we can change that to a smaller one if we want to. I'm going to leave mine as extra large. So we have a optional parameter here which allows us to give the management cluster a name. I am going to give this management cluster a custom name, so I'm going to call it TKG 160-management-01. If you didn't input this name, it would auto-generate a name based on the date and time that this is deployed. For machine health checks, I'm going to enable those, as well as enabling audit logging. And then there's an option here for control plane endpoint provider. So when deployed with 3 nodes, this configuration controls how the traffic is load balanced between the API server of the Kubernetes control plane nodes. So there's 2 options here. There's kubevip and NSX Advanced Load Balancer. In our case, we've deployed NSX ALB, so we're going to use that configuration, which means that the control plane endpoint parameter now becomes optional. We could, if we wanted to, define a specific IP address here, but in our case, we've configured DHCP on the VIP network where the IP address will get assigned, so we don't need to do that. So I'm going to leave that as blank. So that's all the configuration we need for this section. So I'm going to click Next. So the third part of the configuration is related to the NSX ALB. And again, we need to configure connection parameters for how to connect to the ALB controller and how to authenticate against it. I'm going to enter the IP address of our controller host in here, which is 172.19.71.3, and the username and password. And then you'll see there's a requirement for the controller certificate authority. And this needs to be obtained from the ALB user interface. You'll remember that previously when we were configuring ALB, we configured a custom certificate. So we need to download that custom certificate and insert it in here. So I'm going to do that quickly. So switching over to the NSX ALB interface, I'm just going to log in quickly. And then to download the custom certificate, I'm going to navigate to Templates, Security, and SSL TLS certificates. And then this is the custom certificate we created. So I'm just going to click this button which says Export, and you'll see our certificate here. So I'm going to copy that to the clipboard, and I'm going to switch back over to the TKG installer interface. Back in the TKG installer interface, I'm going to paste that certificate, and then I'm going to verify that those credentials are able to connect. So you'll see it says verified, so that's a good thing. That means that it's connected to the ALB controller correctly. And now we need to configure some additional parameters related to the cloud configuration in ALB that we configured earlier. The first parameter is around the cloud name. So if you drop down, the one we want to use is the one we created, which is Tanzu NSX. And then we need to configure the way that the service engines are going to be deployed for both the management cluster and the workload clusters. So if you remember to previous videos, we created specific service engine groups for these 2 types of clusters. So we're just going to select those now. So for the workload cluster, the service engine group name is going to be TKG workload service engine group. And we then have the option to select the VIP network names and CIDRs for the data plane and control plane VIP networks. So in my case, I'm using the same VIP network for the data plane and control plane, which is this one that we created. So TKG-cluster-VIP. I'm going to choose that one, and you'll see it's populated this one as well. And then for the CIDR, we configured the CIDR within ALB for that network. So it'll be 172.1975.0/26, and the same for the control plane VIP network. So moving on to the management cluster configuration. In this case, the service engine group name is different. So I'm just going to remove that. And you'll see that the one we want to use is called TKG-MGMT-SEG service engine group. So we're going to choose that. The network, we are going to use the same VIP network. So the same CIDR and same network names. So that's all the configuration that's required for the service engines. And the last bit of configuration we need to perform is around the cluster labels here. So we're going to add a custom cluster label, and what this does is it will automatically deploy an operator into the clusters that we deploy, and that operator will be in charge of handling if we try to create a specific Kubernetes service type, and it will handle that and integrate with NSX ALB to enable that traffic flow to occur. So the custom label we're going to put in here is type and management. And so what will happen here is that when the management cluster is deployed, it will automatically add this operator into the cluster and allow us to use NSX ALB to load balance the traffic to the Kubernetes API server deployed within the management cluster nodes. So that's the end of the configuration for this section. So I'm going to click next. So the next part of the configuration is around metadata. So you'll see all of these values are purely optional. It's just for ease of management, I guess, and organization. I'm just going to leave them blank, and I'm going to click next. So the fifth section that requires configuration is around the resources, and this is specifically around how the management cluster is going to be deployed within vSphere. So we created a resource pools and VM folders to house the management cluster VMs. So we just need to define those here. So the VM folder which we created was called TKG-MGMT-VM. So we're going to select that for VM folder. We only have a single data store in our environment, which it has already pre-selected. And then for where these VMs are going to be deployed, we're going to select our TKG-MGMT resource pool. And once that's done, I'm going to click next. So the sixth section of configuration is around the Kubernetes network. By default, the CNI provider that is deployed within the cluster is Antrea. You do have the ability to change that, but it is not recommended when integrating with the NSX ALB. So the network name we want to connect these VMs to that are going to be created is the TKG-MGMT-LS, which is the logical segment that we created in NSX. So I'm going to select that. And then the cluster service CIDR and the cluster pod CIDRs are the internal CIDR ranges that are used by Kubernetes. I'm going to leave them as the default. And then I'm going to click next. So the seventh section is around identity management. We have the ability to activate identity management using OIDC or LDAP-S. In our case, I'm just going to leave this disabled for now. So I'm not going to activate identity management. And I'm going to click next. So the second last part of configuration is around the OS image. And you'll remember from our previous preparation for the vSphere environment, we imported the TKG images into vSphere. So this is automatically detected those templates and populated them here. And you'll see our Photon TKG image which we imported. So we want to use that image to deploy these virtual machines. So we're going to select that image and click next. And the last bit of configuration is just around the customer experience improvement program. And by default, participating in this program is selected. If you don't wish to do that, you can deselect it. I'm going to leave it selected, and then I'm going to click next. So that is all the configuration that's required to be able to deploy the management cluster. So I'm going to click Review Configuration. That's going to show us all the configuration parameters that we input into the different sections, broken down in a tabular form. Now, we would usually be able to deploy the management cluster directly from this user interface by clicking the Deploy Management Cluster button. But in TKG 1.6, there is one configuration parameter related to the NSX ALB, which is required for deployment but is not available in the user interface. And so that configuration parameter is not actually populated when we try to deploy the management cluster. So in this case, I am going to export our configuration, and I'm going to add that configuration parameter manually. So we're able to export the entire configuration that we defined previously into a single file, which I'm going to do now, and that will download the configuration into a file on your local machine. So moving back to our Bootstrap machine, I'm just going to Control C out of the Kickstart UI, and so I'm going to make a directory called TKG in the TKO user home directory, and then change into there, and then I'm going to create a file called tkg-managementcluster.config, and in this file I'm going to paste the configuration that I just downloaded. So that's the export of the configuration which we configured in the UI. So you can see all the parameters that we configured. So we're now going to add the one configuration parameter which we couldn't add via the UI, which is required. So the parameter that we are going to add is avi underscore nsxt underscore T1LR, so the T1 logical router. And this is going to be the name of the tier 1 logical router that we created in NSX. But we're going to precurse it with /infra /tier -1s, and then the name of the logical router we created, which in my case is nsxt01-t1-tr. And once we've added that parameter, I'm going to save this file. And then I'm just going to check the contents of the file again to make sure that our parameter is added correctly. And there we can see it added. So I'm happy with that. And we can now use this configuration file to deploy the management cluster from the command line interface using the Tanzu CLI. So the command we're going to use is Tanzu management-cluster create -- file, and then the location of the config file which we just saved. So if we go to our home directory, tkg/tkg-mc.config, and then I'm going to add a verbosity of 6 for logging. So once we execute this command, it's going to come up with the same questions around the way to deploy TKG as we saw in the GUI. So we're just going to say, do you want to configure vSphere with Tanzu? No, we don't want to do that. Would you like to deploy a non-integrated TKG management cluster? That is what we want to do. So we're going to say yes. And then you'll see a bunch of logging come up which essentially is describing the creation of the kind cluster. So it's going to download the node images and then use those to start the kind cluster. It will then deploy the cluster API components and infrastructure providers, which will allow the cluster to deploy the VMs that are required for the management cluster onto vSphere. Once it's got to this point, you'll see now it now integrates with the infrastructure provider and tries to start creating the control plane VMs. So if we switch over to vCenter, we should see some action. So you can see a few things happening here. The first is that it's fetching some content from the content library, and that's because NSX-ALB is starting to create the service engines, and you can see two service engines being created here. You'll also see the first VM for the TKG management cluster get created in vSphere. So both of the service engines are now created and they are powered on. And you'll see that the first control plane VM has been started as well. So it's starting to do its pre-configuration. So you'll now see that the additional control plane VMs and the worker nodes are also getting created. And that is a good sign that the NSX LB configuration has been completed correctly. So the service engines have been onboarded and a virtual service has been created, which allows us to reach the API server and load balance across the different control plane nodes. So we'll just wait for the final control plane VM to be created. So there you see our final control plane is being cloned and started. And if we switch back to the Bootstrap machine, we should get an indication of how close it is to finishing. So you'll see some retry messages here for scaling up, and essentially that's just checking that the control plane is scaling up to 3 nodes, and once those 3 nodes become available, this will stop retrying and will start to complete the final configuration steps, which will involve again installing the cluster API components into the cluster and then pivoting the resources from the kind cluster onto the new management cluster that's been created. So you will now see that our management cluster creation has completed. And from the last few lines of the logs, you can see that the kind cluster has been deleted. The management cluster has been successfully created. And we can change to the context of that cluster by using the kubectl command, which is defined over here. Although it should set us to the context of the management server by default anyway. One other thing that you will see is that the AKO operator has been installed, and that's because we configured it with that specific label in order for it to automatically deploy the AKO operator. So we should also be able to proceed creating workload clusters if we wanted to. We could do this from the Tanzu CLI, and it gives us an example command in order for us to create a workload cluster. But as mentioned before, our context should be automatically set to this management server. So I should be able to execute some kubectl commands just to validate this cluster. So the first one I'm going to do is I'm just going to run kubectl get nodes -o wides, and this should give us all of the control plane nodes, which it does correctly, along with how long they've been up, their Kubernetes version, and their internal IPs, which looks correct because they've all been assigned IPs from that DHCP range, which we set for the logical segment. And you can see all of the naming follows the custom name that we gave or configured in the UI. So the custom name I gave was TKG160-MGMT-01. So you'll see all of our names are preset with those. So we can also, if we run a kubectl get pods -a, we should be able to see all the pods that are running, and you see they're all running correctly, and they've been up for as long as the management cluster has been created. And again, you'll see the AKO operator here, which is been installed because we set that label in the configuration file. So it looks like our management cluster has been deployed successfully. I'm just going to switch over to the NSX ALB UI to show the virtual services which have been created. So I'm going to log into the NSX ALB user interface, and if I navigate over to applications, you will see that our virtual services is now 1 where it was previously 0. And if I choose here virtual service tree and I expand this, you will see our control plane nodes here as pool members for destination traffic. So each node will be accepting traffic on port 6443, which is the Kubernetes API server, and that's being load balanced across our 3 control plane nodes via a NSX ALB virtual service pool. And I can go to some of the other tabs to get some information about this. So you can see that the IP address for our virtual service has come from the VIP pool. So it's been assigned automatically from that VIP pool. So in this case, it's 172.1975.2. The health is currently 90, but that will increase as more traffic hits the API server. If I go to virtual service VIPs, you'll see that same VIP that's been assigned to the virtual service. If I navigate to pools, you will see that a single pool is created which has got 3 servers in it, and those 3 servers are our 3 control plane nodes listening on port 6443, as we saw from the original tree view. We don't have any pool groups. So you can see how NSX ALB has automatically created a virtual service for load balancing and is load balancing traffic across the Kubernetes API server components on the control plane nodes. So in a similar way, if we create a Kubernetes service type on any of the additional clusters we create, it will do the same thing and create additional virtual services to be able to load balance across that. It also gives us a view of the service engine which it is using to perform these functions. So at the moment it's using this service engine, and we can get some statistics around how the service engine itself is performing if we wanted to. So that brings us to the end of this video. Thank you for watching.